Hello students, welcome to the course on chemistry. So in the previous lecture, we have studied what is meant by atom, what is meant by matter and molecules, and what is the structure of atom. Along with that, we have seen what are the subatomic particles of atom. Now in today's video, we are going to discuss about how the electrons are distributed in an atom. So before going to that, see here, as you already studied, atom, it consists of protons, neutrons and electrons. The protons and neutrons, they are present at the center of the atom. So this region is said to be nucleus, and the total charge on the nucleus is positive because the neutrons are electrically neutral, and hence the nucleus has the positive charge due to presence of protons. So thus it is also said to be nucleons, since the neutron has a positive charge, and hence it is also said to be nucleon. Now, around these nucleus, the electrons are revolving around a circular path, and that circular path is said to be shell, and these shells are termed as K shell, L shell, M shell, N shell, so on. And we have also studied how to find the maximum number of electrons that can be present in a given particular shell. So that is calculated by using the formula 2n square. So by using 2n square formula, we will find the maximum number of electrons present in an shell. So now, if we use this formula, then we come to know in first shell the number of electrons present will be 2, and in second shell maximum number of electrons will be 8, and in the third shell it is 18, and in fourth shell it is 32. That we have already calculated. Now again in this orbit, the electrons are found in certain regions. They are not found in throughout the orbit, but they found in the certain regions, and the regions where you find the maximum probability of finding electrons is said to be orbital. So the region where you have maximum probability of finding electrons are said to be orbitals, and these orbitals are also said to be subshells. Orbitals or subshells. So here these subshells are of different types. They are S, P, D and F. And the S subshell, it occupies the maximum of 2 electrons in it. And in P subshell, there are totally 3 orbitals, and in each orbital 2 electrons will occupy, and thus in P subshell the maximum number of electrons present will be 6, and in D subshell the maximum number of electrons will be 10, and in F subshell the maximum number of electrons present will be 14. So remember, in S the 2 electrons, P 6 electrons, D 10 electrons, and F 14 electrons. Maximum this much amount of electrons will get occupied in these subshells. So now In a first shell, there are maximum 2 electrons present, and thus if there is a presence of 2 electrons, then they get easily occupied in S subshell. Those 2 electrons will get occupied in S subshell, and thus in first shell we will find only S subshell, because the maximum electrons present will be 2 in first orbit or first shell, and they will occupy in the S subshell. And in second subshell there is a presence of 8 electrons. So thus those 8 electrons are distributed as, in S subshell the 2 electrons are present. How much will remain? 6 electrons, because 8 electrons are there. Among 8 electrons, 2 electrons are occupied in S, and remaining 6 electrons will go to P subshell. So thus in second orbit or second shell there will be presence of S as well as P subshell. You will find 2 subshells in second orbit. And if we come to third shell, there is a presence of 18 electrons. So again, first 2 electrons will occupy in S subshell. Then 6 electrons will get occupied in P subshell. So here in S 2, P 6. Totally 8 electrons are occupied. Remaining how much? Among 18, 8 electrons are filled in S and P. The remaining 10 electrons will move to D subshell. So thus in D subshell or in D orbital, the remaining 10 electrons will occupy, and thus in third shell there will be presence of S, P and D subshells. Again in fourth shell 32 electrons are there. First 2 electrons will occupy in S. Remaining 6 electrons will occupy in P, and 10 electrons will occupy in D. So totally 18 electrons have been occupied. Remaining how much? 14 electrons. Those 14 electrons will occupy in F subshell. So in this manner, in the first shell S orbital is there. In second shell S and P orbital is there. In the third shell S, P, D orbitals are there. And in fourth shell S, P, D and F orbitals are present. So thus, by knowing where the electrons are present and in which subshell the electrons are present, we will able to describe the distribution of electrons in the atom. So whenever we will get any element, we have to write the distribution of electrons present in the atom. And before going to that distribution of electrons, we have to know certain terms related to atom. First one is atomic number. It is represented as Z. So atomic number means the number of protons present in an nucleus of an atom. It is called as atomic number. So how many number of protons are there? That is represented by using atomic number. So suppose if I say the atomic number is 10, then the number of protons present will be 10, because that Z will represent number of protons. If the atomic number is 5, then the number of protons is 5. So if the number of protons is 5, then what would be the number of electrons? The number of electrons is also 5 when the number of protons is 5, because the number of protons is equal to number of electrons. So whatever the number of electrons is there, that is equal to number of protons. So suppose if the number of electrons is 10, then the number of protons is also 10. So thus we can say the atomic number, it will represent or it will be defined as number of protons. But we can understand in that atom the number of electrons is also equal to number of protons. So whenever they give the atomic number, then by using that we will come to know how many number of electrons are revolving around the nucleus. So remember the atomic number. Then along with this, the another term is atomic mass number, which is represented by capital A. It is nothing but the number of protons and neutrons present in a nucleus of an atom, and it is called as atomic mass number. So how many protons and neutrons are present in the nucleus of an atom will be represented by atomic mass number, and it is denoted as A. So remember these two terms related to atom. Now, what is element mean? There are totally 118 elements are there, and among them around about 90 elements are naturally occurring and 28 elements are artificially prepared in laboratories. And the element means it is the purest form of a matter containing same kind of atoms. Means whenever we say an element, it consists of same kind of atoms having same atomic number as well as same atomic mass number. Along with that, now electronic configuration. So electronic configuration means the which describes how the electrons are distributed in its atomic orbitals. So now we will study the distribution of electrons in its atomic orbitals, and that is said to be electronic configuration. It mainly describes the distribution of electrons in atomic orbitals. And to write the electronic configuration of an atom, we should know certain principles related to that. The first one is Aufbau principle. The Aufbau means build up. So how the electrons are built up in the atom, that it explains. According to Afbau principle, it states that in a ground state of an atom, the orbitals are filled in order of their increasing energies. So first the electrons will move to the orbital having lower energy, then it goes to the higher energy, again it goes to the still higher energy. So thus it gives how the electrons are filled in the orbitals. It will filled in the order of their increasing energies. Okay, and here is the chart which explains about the filling of electrons in the orbitals according to their energy. So first electrons will fill in 1s, and then the electrons will fill in 2s, then they will fill in 2p, then go to 3s, then 3p, 4s, 3d, 4p, 5s. So in this manner the electrons will go on filled up. So first you have to see or you have to remember this diagram in order to write the electronic configuration of any element. So if you remember this, according to this we will go on filling up the electrons in the orbitals. So first electrons will enter into 1s. After filling this, 2s. After filling this, 2p. Then 3s. Then 3p, 4s. Then 3d, 4p, 5s. Then 4d, 5p, 6s. In this manner, the electrons will go on filled up in an atom. So remember this diagram. Another rule is Hund's rule of maximum multiplicity. So now, if there is a presence of s, p, d orbitals in the same subshell, okay, where the electrons will fill first, whether they will go to d or p or s. Here, according to Hund's rule, they will fill up first in s and then in p and then in d. In a s subshell, there is a presence of only one orbital, and in p subshell, there is presence of three orbitals, and in d subshell, there are totally 5 orbitals are present. And in s subshell, remember each orbital will occupy 2 electrons. So in s only one orbital is there, so thus we will have 2 electrons. And in p orbital, totally how many electrons it will hold? 6. So in each box that represent orbital can have 2 electrons. So 2, 2, 2. Totally there will be 6 electrons will be filled up in p subshell. So now to fill this p subshell, first we will fill each orbital by single electron. After filling the single electrons in each orbital, we will start to pair up the remaining electrons with the orbital. Okay, so first whenever we have the electrons, then those electrons will be filled in the orbitals such that they get singly occupied by the electron. After that, we will start to pair up the electrons. Now if we consider d subshell, let's say 6 electrons are there. Now to fill those 6 electrons, we will not pair up in 3 orbitals only. We can pair up like this. So 2 electrons, 2 electrons, 2 electrons. But this is the wrong method. According to Hund's rule, we have to fill the electrons in such a manner that each orbital first get singly occupied. And then how many electrons are remained? 5 electrons are filled. Totally 6 electrons are present. So remaining 1 electron will get paired up. So in this manner, we have to fill the electrons in the orbitals. So that is Hund's rule. It states that pairing of electrons in the orbital belonging to the same subshell does not take place until each orbital gets singly occupied by electron. So remember these two rules, Aufbau principle and Hund's rule of maximum multiplicity. Now by applying all these rules, we will write the electronic configuration for different elements. So first we will see the hydrogen atom. The atomic number of hydrogen is 1. And if the atomic number of hydrogen is 1, there is a presence of 1 proton and 1 electron. Okay, so here to write the electronic configuration describes how the electrons are distributed. Here you can observe only one shell is there, that is considered as first shell, and 1 electron is there. If 1 electron is there in the first shell, only 1 subshell is there, that is S, and that one electron will get occupied in S subshell. So this one represent the number of shell and S will represent subshell, and this one will indicate electrons. So this is the electronic configuration of hydrogen, and this is how we can write the electronic configuration of hydrogen atom. So in hydrogen atom, in first shell, in S subshell, one electron is there. This is how the electron is distributed in hydrogen atom. Then second one is helium. The atomic number of helium is 2. Okay. And now what would be the electronic configuration? Again, in first shell, 2 electrons are there. So first shell. So since 2 electrons are there, they will go to S subshell and they will get occupied in S subshell. So 1s2 is the electronic configuration of helium. Next, the third one is lithium atom. So in a lithium atom, there will be presence of 3 electrons because the atomic number of lithium is 3. How we can write the electronic configuration? See, in first shell, in S subshell, 2 electrons are there. Then the next electron will not get filled in first shell because the maximum number of electrons is present will be 2, and thus in the third electron it will goes to second shell. There also it will first fills up in S subshell and that electron will get occupied. So this is the electronic configuration of lithium, 1s2, 2s2. So the fourth one is beryllium. Here again, atomic number of beryllium is 4 and the electronic configuration of beryllium becomes first shell, S subshell, 2 electrons, second shell, S subshell, 2 electrons. So thus this is the electronic configuration of beryllium. Then fifth one, boron. So the atomic number of boron is how much? It is 5. So thus electronic configuration becomes first shell, S subshell, 2 electrons, second shell, S subshell, 2 electrons. But here totally 5 electrons are there, where we can fill the fifth electron. Yes, it can occupy maximum 2. Thus we can write 2s2. We cannot able to write 2s3 because in S maximum it will occupy 2 electron. Then where it goes? Will it go to the next shell? No. It will remain in second shell. But in second shell, another subshell is there, that is P. There the another electron will get occupied. So thus the electronic configuration of boron is 1s2, 2s2, 2p1. Then sixth one, carbon. The atomic number of carbon is 6. Therefore, the electronic configuration will be written as 1s2, 2s2, then 2p2. Because the 2 electrons will remain, those will filled in p orbital. So this is how we can write the electronic configuration of different elements. We will write some more electronic configuration of different elements in next video. So this is all for now. Thank you.